About polynomials. Mono means 1, bi means 2, tri means 3. Anything above 3 is poly. So in our book we have a couple that are not necessarily in the correct order. So first off, tell me how I would name that. How many terms does it have?
It's poly.
4 terms, so it's a polynomial. Okay. Is it in the correct order?
Yeah.
Yes, so my exponents start smallest or start at the largest and go smallest. What are the coefficients?
3 and the 9.
Okay, so I have a -3, +9. What about here?
Well, it's a 1 technically.
Okay, that's a 1. So what's my leading coefficient?
1.
1. Right, the leading coefficient is the first term in the equation, whatever the coefficient is. Bart?
So that -3 is not considered a -3, so it's considered a coefficient 3.
It is a coefficient, but it's a -3. That's the number.
How come the -27? How come 27 is not a coefficient?
Because it doesn't have a variable attached to it. So it's a constant term. Okay. How about this one? X plus 2x squared minus 3. How would I name it?
Trinomial.
Trinomial. Is it in the right order? So how should I rewrite it?
2x squared plus x minus 3.
Okay, so what are my coefficients?
2 and 1.
2 and 1.
When you have a variable and a number, are they equal?
What do you mean, are they equal?
Well, you put x plus x minus 3.
I need to rearrange so that my strongest exponent is the first one in the equation. So this is an x squared.
So exponents go before whole numbers.
Exponents go before whole numbers. Whole numbers are usually the last term. How about 5x squared y minus 2xy? How would I name that one?
Binomial.
A binomial. What are my coefficients?
2.
5 and a -2. Okay, how about this one? How do I need to rewrite that?
-x squared plus 9.
-x squared plus 9. What's another way I could rewrite that?
-1 in parentheses x squared plus 9.
Okay, we will use that a lot. If our leading coefficient is a -1, we will often pull it out.
Then what do you do? What do you use? Why?
We'll get there. We'll get there. Let's go into adding and subtracting polynomials. Okay, first one they give us is 0.7 n cubed plus 4n squared plus 8 brackets plus brackets 0.5 n cubed minus n squared minus 6n, another set of brackets, 3n squared plus 7n minus 10. Okay, you need to get rid of all those parentheses. Remember our associative property of addition? I can rearrange things.
So you have 11n to the 5th.
Not yet, hold on. Do I need to do anything to get rid of this first set of brackets? No. Okay.
Sorry, I didn't see the 0.7.
Plus 4n squared plus 8. Okay. How about my second set of brackets?
Nope.
No? I just want to rewrite it. Okay. What about my third set of brackets?
Times everything by -1.
Okay, there's that floating -1. So I distribute first. What's -1?
Minus -3.
Okay, -3n squared, and then distribute that -1 again.
Minus 7.
Minus 7n
Plus 20. Or plus 10.
plus 10. Okay, now I need to put like terms near each other. So let's start with our n cubes. What other n cubes have I got?
5n cubed.
Okay, I have a plus a 5n cubed. I have 0.7n cubed plus 0.5n cubed. Okay, what's my next exponent?
N squared.
N squared. So I have a plus right there. Do I have any other n squareds? Where?
Minus n squared.
Minus a 1n squared
Minus 3n squared.
and minus 3n squared. Okay, what's my next exponent? Not yet.
7n.
Okay, I have a single n. I have a -6n and -7n. Okay, now what whole numbers do I have left?
The 8 and 10.
Plus an 8 and plus a 10.
Where did that end?
Which one?
That last end, when I said 8, you said we had an end.
7n? I have a -6n right here and a -7n right there.
Okay, so the next number was 8, but you jumped to variables first and add all those.
So you want to start with your strongest exponent, which is cubes,
Okay.
and then go down and leave your whole numbers for the end. Okay, so let's add 0.7 plus 0.5,
1.2.
1.2 n cubed. Okay, now my n squared, what do I have here? 0 n squared. Okay, so we'll just not write anything for that. How about over here?
13n.
13n, positive or negative?
Negative.
So minus 13n
Plus 18.
plus 18. Alright, so adding and subtracting polynomials. It helps if you can keep your like terms together. That's where everybody gets thrown off usually, if they try to add an n cubed and an n squared. So rewrite it, put your like terms next to each other. Let's do another one. X cubed minus 5x plus 9 minus x cubed plus 3x squared plus 2x minus 8. Okay. What do I need to do to get rid of this set of parentheses? Okay, I need to distribute the -1 through. So let's rewrite it. I have x cubed minus 5x plus 9, and then distribute this through. -1 x cubed, and then again -3x squared, -2x, positive 8.
Did you have to write that -1x cubed?
The problem they gave me was a subtraction problem. They wanted me to subtract this equation from this equation. So to get rid of the brackets, I have to distribute the -1 through.
Right, so that first time you did -1, I would have not put the 1, I would have just put -x squared. Have that not?
No, you can do it that way if you want. Okay, what like terms do I have?
X cubed.
I have an x cubed negative x cubed. So I'll have x cubed minus 1x cubed. Okay, what else? What's my next strongest exponent?
3x. Negative 3x.
Negative 3x squared. Do I have any other x squareds? No. Okay. What next?
5x minus.
Negative 5x. And negative 2x. And I have whole numbers left. Plus 9, plus 8. Okay, so combine x cubed minus 1x cubed is?
Cancels each other. 0.
0. And then negative 3x squared. Is there another x squared? Okay. There's negative 3x squared. Negative 5x minus 2x.
Negative 7x.
Negative 7x
Plus 17.
plus 17. Okay, this is called the horizontal format because everything runs along the horizontal. We have another format called the vertical format where you put one above the other like a standard addition problem. I don't like that format. If you like it, feel free to use it. It makes it a little more tricky because you often don't have, this doesn't have an x squared term in it anywhere. So to keep that straight, I would have to rewrite it with a placeholder for the x squared. If you prefer that type, go ahead and use it. It doesn't matter, you should get the same answer either way. So vertical and horizontal formats. So adding and subtracting, just make sure you keep your like terms together. So now we're going to talk about multiplication of polynomials. Alright, my first example is 2a, negative 2a squared times a squared minus 2a plus 1. Okay, so I need to distribute. What's negative 2a squared times a squared?
Negative 2.
Okay, so remember that's really a 1. So what's negative 2 times 1? Negative 2, and then a squared times a squared. Remember, this is our product property. What's the product of 2 times 2? 2 plus 2. Okay. A to the 4th. I have an a squared times an a squared. Okay, distribute again. So negative 2 times negative 2.
Positive 4.
Positive 4. And then a squared times a.
A squared.
So a squared times an a.
Oh, a to the cubed.
Yes, right? So I'm using my product property. So 2 plus 1 is 3. Okay, and then distribute one more time. What's 1 times negative 2a squared?
Negative 2 squared.
Negative 2a squared. Okay. Do I have any like terms that I need to combine? Nope. Okay. So that's that was example A. To example B is 2z plus 1 times z minus 2. Okay. So multiplication of polynomials, if I only have one term, it's the same as distributing through. Now I have two terms, so I have two binomials.
You have to multiply both of the first terms against the second terms.
Very good. I need to multiply both terms. So let's start here. 2z times a z.
2z squared.
Okay, so I have 2 times 1 is 2. And then a z times a z, 2z squared. And then 2z times negative 2,
4z.
negative 4z. And then 1 times a z
1z.
plus 1z. And then 1 times negative 2. Negative 2. Do I have any like terms I can combine?
Negative 4z and positive 1z.
Okay, the 4z and the 1z. So this will turn into 2z squared
Minus 3z.
minus 3z minus 2. Okay, 2v minus 3 times 4v squared plus 6v plus 9. Okay. So what's the name of a two-termed equation? Binomial, and then a three-term trinomial. So now I have a binomial times a trinomial. So same rules apply. Everything has to multiply. We'll start with my 2v.
8v cubed.
8v cubed
12v squared.
plus 12v squared plus 18v. Okay. Minus 12v squared
minus 18v.
minus 18v minus 27. Okay, like terms together. Do I have any other v cubes?
Nope.
Okay. So 8v cubed
Yeah, the 12v squared and negative 12v squared, which cancel each other.
Okay, 12v squared and negative 12v squared. What's my next term?
18v and negative 18v.
An 18v and a negative 18v. So those are going to cancel.
We're left with negative 27.
So 8v cubed minus 27. Okay. This is called the FOIL method. What does FOIL stand for? Do you know? First, outer, inner, and then last. If I have, let's say I have x plus 3 times x minus 4. First, so that's the first terms of my brackets. X times x. And then my outer terms, that's this one and that one. So it's x times 4. Okay. Positive or negative?
Negative.
Okay, then my inner terms are these two right here in the middle. Plus the 3x, and then my last terms, negative 12. Okay. And then typically my two middles are going to combine.
Negative 1x.
Okay, so I'll have x squared
1x.
minus 1x minus 12. Okay. We're going to use the FOIL method a lot. First, outer, inner, last. Example A is 5n minus 1 times n plus 2. Okay, so first, which are the first terms?
5n.
5n times n.
5n squared.
5n squared. Then there's my outer. 5n times 2.
10n.
10n. Here's my inner.
Negative 1n.
Negative 1n. And my last.
Negative 2.
Negative 2. Then combine like terms.
5n squared plus 9n minus 2.
5n squared plus 9n minus 2. Two b plus 3 times 5b minus 6. Okay, first. 10b squared. Outer, minus 12b. Inner, 15b. And last. Okay, combine like terms.
MB squared plus 3B minus 18.
Okay. We have a couple of special equations that they follow the same pattern, but they're kind of a shortcut. We can do shortcuts. The first one they give us is x plus 7 times x minus 7. Okay. This is called a binomial conjugate. It's the exact same term. One is positive and one is a negative. If I do this out the long way, what do I get? So
X
first,
squared.
x squared
Negative x, 7x.
minus 7x
7x.
plus 7x
Minus 49.
minus 49. So the trick about a conjugate is that these two middle terms will always cancel out.
Leaving with x squared minus 49.
So it will be a positive 7x and a negative 7x. That will be 0. So my answer is x squared minus 49. So I can skip those middle steps if I want to. You don't have to. You'll get the same answer. But a conjugate is where I have the same thing inside my brackets with different signs. One's positive and one's negative. So let's say I have 3x plus 4 times 3x minus 4. Are my terms the same? Yes, so they're called conjugates. So the shorthand way is times my first together, 9x squared, and my last together, minus 16. Go ahead and do it the long way if you want. It's just kind of a special exception. Binomial squares. Down on the bottom of page 94, they have it written out like this: a plus b squared. How would I write that out using two sets of brackets?
A plus b times a plus b.
A plus b times a plus b. Okay, so then FOIL it with me. A times a.
A squared.
A squared. A times b.
AB.
And then a times b.
BA.
Again, ab. And then b times b.
B squared.
B squared. Okay. So then combine my like terms. A squared plus 2 times ab plus b squared. Alright. No, that doesn't make a lot of sense, but what if I have it written like this? X plus 5 squared. How do I write that out?
X plus 5 twice.
X plus 5 times x plus 5. Okay, now FOIL it.
X squared.
X squared
5x.
plus 5x
5x again.
plus 5x again. Okay, combine like terms.
X squared plus 10x plus 25.
Okay, so the shortcut is knowing that I can go from this to this and skip all those middle steps. Right? So I'll have x squared, there's my first term, 5 squared, there's my last term, and then in the middle I would have 5x times 2. So it's just another shortcut. You'll get the same answer if you FOIL it out and then add terms, but if you take a shortcut way. So binomial squares. What if I have it a negative? What if I had x minus 3? How should I write it out? X minus 3 times x minus 3, and then if I FOIL it, what do I get?
X squared.
X squared.
Negative 3x.
Negative 3x. Plus the 9. Combine like terms. X squared minus 6x plus 9. So same shortcut here. X squared, negative 3 squared, so there's my first and my last terms. And then it's 3x times 2. It's just little shortcuts. If you're more comfortable FOILing it out and doing it the whole way, go right ahead.